Alright guys, this video is called Systems of Equations. It is section 7.1, so we're jumping ahead now to chapter 7. Y'all did fantastic on your tests. This here is my second best drawing of the year so far. It is in honor of Columbus Day, and this is Scotty discovering America. Alright. So, if we're given a system of equations, these equations can be lines, they can be parabolas, etc. What we're looking for to find the solution to the system of equations, basically, is where the graphs of these equations intersect. Alright, and what that means is, when we have a line, we can take a point, any point on this line that I'm pointing to right here, and if we plug it into that equation for the line, it will be an equal result. So, for instance, the line y equals x, if we plug the point 1, 1 into it, it'll be 1 equals 1, right? We plug 1 in for x, we plug 1 in for y, it'll be 1 equals 1. That will work out for any point on here. You pick a point, plug it into the equation for that line, it'll be a true result. This point here, where they intersect, is the point that is true when you plug in for both equations. So if you plug that point into both of these lines, it will give you a true result. Alright, and so you can also see we can have the equation of a parabola and the equation of a line, and then here we'll have two different spots where the graphs intersect. And so there's two different solutions to the systems of equations. At both these spots, you can plug that point in, the line and the parabola, and you'll get a true result. I'm going to go ahead and show you what I'm talking about here. Alright, so check out these two lines here. These lines intersect at the point negative 1, 2, 3, negative 1. So it looks like they intersect at negative 3, negative 1. Well, let's check this real fast. If we plug this point into here, we're going to get negative 1 equals, make sure you keep that negative sign, so it's negative 3 minus 4, which is really plus 3, right? Minus the negative is plus, so it's plus 3 minus 4, so we get negative 1 equals negative 1. And you see that that is true. That was a bad square edge here. Alright, we give a little check. Yeah, that's true. That's because this point falls on that line. This is the line down here. Slope of negative 1, intercept of negative 4. Now let's plug it into this line. Okay? Negative 1 equals negative 3 plus 2. We get negative 1 equals negative 1. Boom. Also true. And that's what that means. That is, if the system of equation, this will be the system of equations, right? Your system of equations is these two equations. Your solution is a point where they intersect. Negative 3, negative 1. And it is a solution because when you plug it into both of them, you get a true result. When I mean true result, it's this. It equates. Okay? If we pick the point 0, 2, for instance, this is not a solution to the system of equations. It will work for this point, right? It will be 2 equals 0 plus 2, which is 2 equals 2, which is true. But if you plug it in here, it's going to be 2 equals 0 minus 4. That's not true, because it's not the intersection point. Alright, here's how we can find this solution, not just by looking at a graph. We're giving two equations. We can solve one of the equations for one of the variables. So I'm going to solve this equation for x. We're going to find x equals 2 plus y. And all I did was move y to both sides, okay? Then I can take this, and if I take this equation over here, it's equal to x plus y equals 4. I can plug in 2 plus y for x, just like we've been doing recently with functions. It's 2 plus y equals 4. Which is 2 plus 2y equals 4. Divide everything by 2. And we get 1 plus y equals 4. And we get y equals 3. So we have the y point. So if I'm going to draw this graph, it looks like this graph right here is going to be the slope of negative 1. If I just write it as slope-intercept form, it's going to be negative x plus 4, right? So it's going to be 1, 2, 3, 4, slope of negative 1. This one's going to be equal to y equals x plus 2. So it's going to be 2. It's going to look like this. So these are the two lines we're working with here. You can already tell. Well, it looks like that is actually at 3. See? Y equals 3. Now let's find the x-coordinate. All we need to do to find that is plug that back in up here. So if we take either equation, so I'll take the first one, I'm going to say x plus y equals 4. I'm going to plug 3 in for y, so it's x plus 3 equals 4. I can see x equals 1. So the solution point is 1, comma 3. And you can see that. Ready? 1, 1, 2, 3. That's 1, comma 3. Alright? Let me give you another quick example. So if we have y equals 2x minus 4, and we have y equals x plus 1, well, I can just take this and plug it right in for y, right? Because that's what y is equal to. So we can plug it in. We'll get y plus 1 equals 2x minus 4. I'm going to subtract the 1. So I'm going to get 1 equals x minus 4. Bring 4 to both sides. We get x equals 5. Then we take this, plug it in here. So we're going to get y equals 5 plus 1. Because it was y equals x plus 1. But I plugged in 5 for x. So y is equal to 6. And our solution point is 5, comma 6. Remember, I know I'm going probably a little bit too fast right now. Pause it. Just look at it. Go back if you have to. It's all good. It's all good. Alright. We can do this with a parabola, right? This is going to be a parabola. So I'm going to take this, and I'm going to solve for y. We're going to get y equals 2x plus 1. All I did was bring the y over, and I brought the 1 over. So now we take this, and we plug it in for y. So we're going to get x squared plus 4x. Instead of minus y, we're going to do minus 2x plus 1. See? Plug that right in, just like we've been doing. It's equal to 7. So then I get x squared plus 2x. I have plus 1, but I'm going to subtract 7 from both sides, so it's going to be minus 6. It's equal to 0. Okay? Let's go back real fast. I made a mistake here. It should have been minus 2x plus, it's also minus 1, right? I just made a mistake that a lot of you guys make. So it's going to be x squared plus 2x minus 1 minus 7, which is minus 8. And we're going to find that this factors down to x plus 4 times x minus 2 is equal to 0. So our x coordinates are going to be 2 and negative 4. Because whenever 2 is 0, it's going to be equal to 0, and when negative 4, it's going to be negative 4 plus 4, which is 0, so the whole thing will be 0. Okay? Now we got to plug those points back in. Okay? So I'm going to first plug in 2 for x. I have 2 times 2 minus y equals negative 1. So it's 4 minus y equals negative 1. We're going to find y equals 5. So that point is going to be 2, comma 5. Now I'm going to plug in negative 4. So we're going to get 2 times negative 4 minus y equals negative 1. negative 8 minus y equals negative 1. And we're going to get y equals negative 7. So that point will be negative 4, comma, negative 7. Alright, all I'm doing is solving for y here. Okay, so these are equal. These are equal. Then I'm taking this and plugging it in there. That's what I did here. After I did that, I was able to factor it. So I found that when x is equal to negative 4, they're going to be equal, because it'll be negative 4 plus 4, which is 0, so times that, it's going to be 0, and when it's equal to 2. Then I went and I plugged these points. So these are the two x values. Because remember, this is a parabola. So it's going to be a parabola and a line. So there's going to be two solution points. Alright, and the x values for them are these two solution points, okay? 2 and negative 4. Then to find the y values, I took these and plugged them in for x. So here I plugged 2 for x, and here I plugged in negative 4 for x. Alright, question. Is there always a solution? Well, let's check this out. We're going to find that this is equal to, y equals x plus b. It's going to be y equals x minus 4. So these are equal. This is equal to y equals x squared plus 2. Alright? So I graph these. This is y-intercept at negative 4. 1, 2, 3, 4. Slope of 1. This is a parabola shifted up to. It's going to be here. These graphs never intersect. Therefore, when I go through this, there will not be a solution. These never intersect. There is no solution. So the answer is no. There is not always a solution. Okay? I would suggest going back, and if it's not clear now, go ahead and read it again, or look at it again, or take a second and look in the book. But we're going to go over this in class, so don't freak out. It's pretty simple. Basically, we're looking for where these lines intersect, okay? Two lines are always going to intersect at one point. Always, unless they're parallel, which we'll see. Two parallel lines never intersect, okay? A parabola and a line might not ever intersect. They might intersect twice, okay? Alright, here's my example of a parallel line. Well, this is equal to, if we divide out both things by 2, we're going to see y equals 2x minus 4. And you'll see that these are going to be 2x plus 4. So this is a line going through, first one's a line going through negative 4. Second one's a line going through 4. The same slope. See? They both have the same slope. Therefore, they will never intersect. Okay? So in this situation, no solutions to the system. This is the system of equations. There's no solution. They never intersect. This is our system of equations here. There's no solution again because they're parallel lines. Parallel lines never intersect. Questions?
Just sit right back and you'll hear a tale of a fateful trip that started from this tropic point aboard this tiny ship. The mate was a mighty sailing man, skipper brave and sure. 5 passengers set sail that day for a 3-hour tour. A 3-hour tour. The weather started getting rough. The tiny ship was tossed. If not for the courage of the fearless crew, the